As we move through solving quadratics, we've learned how to find the solution, the roots, the zeros. That all means the same thing by using factoring. We've learned to do it by just finding the roots by using square roots. We've learned how to complete the square by making it factor into a perfect square trinomial. And so then we ask ourselves, where's the formula? Because it's math and there's always a formula. So where's the formula that I can just plug it in and be sure that I get the right value? Well, there is a specific formula and it's called the quadratic formula. And so then the question is, well, why don't we always use the quadratic formula? Well, sometimes if I am looking at x squared plus 2x plus 1, I know that this factors. I can see the factors in it. I know that 1 times 1 is 1 and 1 plus 1 equals 2. So I can quickly find my solution by factoring. So sometimes factoring is a lot faster. Sometimes finding the square root, x squared equals 9. I can take the square root of both sides, x equals plus or minus 3. That was a lot faster than using a quadratic. So sometimes using our other ways are just a lot faster. And because the quadratic formula has several negatives and some squares and different things, a lot of times it's a lot easier to make a mathematical error with the formula. However, nonetheless, we can use the quadratic formula to solve for our solutions, to solve for that x value. Again, we are looking for x, right? We are looking for where it crosses the x-axis. Okay, the number one rule for using the quadratic formula is that your equation must be in standard form. All of your terms must be on the exact same side. If they are not all on the exact same side, you must get them all on the exact same side. Okay? And then once it's all on the exact same side, the coefficients are always in order. So we always have A will be our squared term, B will be our non-squared term. So in this case, this should be an x. And then our C will be our constant term. And so it's important that whenever we have an equation, for example, if we had x squared plus 5x minus 17 equals 0, and I'm looking at that going, 17 is a prime number. I'm not going to be able to factor. I have an extra x value, so I can't find the square root. I could use complete the square, but maybe I don't quite understand that concept. I'm going to use the quadratic formula. The most important thing is to go ahead and list your terms, A, B, and C. Always do it in order, A, B, and C. The coefficient of my first term is 1. A is 1. The coefficient of my second term is 5. The sign must go with it. If this was minus 5x, then that B would be a negative 5. And C is negative 17. Once you have your coefficients listed for your A, B, and C, then plug them into the quadratic formula. I do not recommend just looking back and forth at the formula, at the equation, and plugging them in without actually writing down what your terms are. Okay, so then we look at it and we go, well, this entire thing looks really complicated. How did we get there in the first place? Did somebody just throw all these letters together? No, they didn't. So let's look at some things that look really familiar to us to help us remember the quadratic formula. And there are several really great songs that you're welcome to look up to find that as well. So the first one, we've got negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, if I were to separate out this negative b over 2a, this was the equation that we were given as a cheat to find x of our vertex. So anytime we had a quadratic, When we wanted to find the x value of the vertex, we take negative b over 2a, and that would give us the x value of our vertex. So the x for the vertex. So we have part of the formula for finding the x value of our vertex, because isn't that important to have for our x value? When we did roots, we knew that whenever we take the square root of a number that wasn't already squared in the first place, we have two options. So we had to add plus or minus. So again, we're using the roots portion where we had to have a plus or minus. We've got that in there. And then we have a radical that is b squared minus 4ac. And this is a special term called the discriminant. Not the square root part of it, but only the radicand part of it. Simply the b squared minus 4ac is called the discriminant. Okay? Why? Why is this important? The discriminant, that b squared minus 4ac, comes from the word to discriminate. It means to recognize a distinction or differentiate between something. So this discriminant helps us recognize how many solutions our equation should have. So it's our double check. If we think back to what are all the tools that we now have in our toolbox for looking at a quadratic and solving and making that graph. Well, we know how to find its direction, whether it's up or down. We know how to find the shape, whether it's skinny, basic, or wider. We know to look and see if it's on the origin or off the origin. We know how to find the vertex, with the negative b over 2a. We've got our x value. We know that that gives us our axis of symmetry. So now the discriminant is just another tool. We know the discriminant, it will tell us the number of solutions we should be expecting. So if our discriminant tells us that we should have two solutions and we end up with only one solution, we have a problem. So it's just another double check. So to think about it, if we had, if your discriminant is less than 0, if your discriminant is negative, so say we have negative 4. So the discriminant here would be negative 4. So if it is less than 0, that means that there are no solutions. That means your graph never crosses the x-axis. It is either fully above the x-axis or it is fully below the x-axis. If your determinant is equal to 0, so if the square root is equal to 0, then that means there is only one point that is a solution. There's only one point that touches the x-axis, and that point will be your vertex. Okay? If your discriminant is greater than 0, that should be 0, greater than 0, so it means it's a positive number, then that means you have two solutions. It will cross the line twice. So the discriminant is always fully underneath it. And so when we think about how that works, if I have my negative b plus or minus, and I'm going to use this, my discriminant right here. We're just going to move it in and out. Okay? If my discriminant, if this whole part here is negative 4, okay? I now have an imaginary number. I have an I involved. So since it's imaginary, it didn't actually cross the x-axis anywhere. So I have no solution. So that's why we have 0 solutions there. Now, let's look at it. If my discriminant comes out to be 0 under here, then that means this entire part can just go away. When it all goes away, because the square root of 0 is 0, and plus or minus 0 is nothing, like it doesn't change it at all I am left with is the negative b over 2a, which was the formula for the x value of my vertex. So when it equals 0, when that discriminant equals 0, I only have one solution, and that solution is the vertex. So we can see how that makes sense, because it's just all we get left with is our vertex value. But when I end up with a real number underneath, I meant for that to be 21, then I have a number plus my term underneath, my discriminant here, term underneath my radical, and I have it subtracted. So I have both a positive and a negative form of it, which will give me two separate answers. So when it's positive, I will have two options and I will have two solutions. So that's how the discriminant works. Okay, so let's just, for the quadratic equation, simply plug and play. We ask ourselves questions to figure out if we want to use it, and then we identify our values, and then we're going to simply plug them in. So I've got 2x squared plus x equals 5. So the very first problem that I have is that everything is not on the same side, so I'm going to move my 5 over, which means I've subtracted it from both sides. I'm left with 0. Now I'm in standard form, and I can move forward. So I asked myself, can I factor this? Well, yeah, I could, but not easily. Can I take the root of it? No, because I have two different x families there. Could we complete the square? Yes, I could absolutely complete the square. It's going to involve a lot of fractions, and I don't personally like working with fractions. So let's just go ahead and use the formula. So the first thing that I'm going to do is identify my values, a, b, and c. A is the coefficient of my x squared, so a is 2. B is my coefficient of x. There is no number written there. That means it is the number 1. C is negative 5. So now that I have a, b, and c, I'm going to take my formula, negative b plus or minus the square root of b squared minus 4ac over 2a. And I'm simply going to plug in everywhere that I see b, I'm going to put the number 1. Everywhere I see a, I'm going to put 2. Everywhere I see c, I'm going to put negative 5. So in this case, I had a negative b. I would say that this section is the number 1 section for errors because it is a negative of the number that is already there. So either we end up with negative 1, or what if b were negative 1 in the first place? Then I would have a negative of a negative 1. I highly recommend to use parentheses for this b so that you do not lose this negative sign or just add it in with whatever sign is already there. So if b starts out as negative, then you should end up with a positive number. If b starts out as positive, then you should end up with a negative number for that one. Okay, we're going to plug in b underneath, plug in a and c, and we end up with negative 1 plus or minus the square root of 41 over 4. So we can see that we couldn't factor that easily. Roots was not fun with that. And so in this case, using the quadratic formula was valuable. So it does have two solutions. It has negative 1 plus the square root of 41 divided by 4, and it has negative 1 minus the square root of 41 by 4. You would need to solve for both of those to find your two solutions. All right, in our second example here, we've got x squared minus x equals 5x minus 9. Again, we cannot move forward because everything is not on the same side. So the very first thing that we're going to do is we're going to move everything to the same side. So I would subtract 5x and I would add 9 and move it over, subtract 5x and add 9. What we do to one side, we do to the other. So I now have x squared minus 6x plus 9 is equal to 0. So can it factor? Yes, it can factor. Can we take the root? Not really. Can we complete the square? We didn't need to do that because it could factor. In this case, I'm looking at 9 going, are there any two numbers, same numbers of 9, or any numbers of 9 that multiply to be 9 and add up to be 6? Yes, 3 and 3. So I needed them to add up to be 6, but they needed to be a negative 6. So we have two negatives. So I had x minus 3 gives me, in both cases, x is simply 3. If we notice, this is also x minus 3 squared, like that. So that harkens back to both our vertex form and to the roots. So it has one solution, and so I know that this is a vertex. So technically, my discriminant should be 0 because I just got one solution for that. So let's just check it. So my A value is 1. My B value is -6, and my C value is 9. So we're going to plug all of our numbers into our equation. And underneath our discriminant, for our radical here, underneath the radical, we get 36 minus 36, which equals 0. So it erased my entire radical, and I was simply left with 6 divided by 2, which gave me 3. So I proved with the quadratic formula that my original answer was correct. Okay, so let's look at this third example. -x squared plus 2x equals 2. Again, the problem is that it's not in standard form. I need to move my 2 over by subtracting it from both sides. I set the entire thing equal to 0. Can it factor? No. Can we take a root? Not easily. Could we complete the square? Yeah, but there's several negatives involved, and we just don't want to go there on that one. For this one, we're going to choose to use the formula. Okay? So again, we are going to identify our values. A is equal to -1. B is equal to 2. C is equal to -2. So at this point, we simply plug and play. We put in all our numbers. In this case, we got a negative underneath our radical. So right away, we know that this has no solution for it because they are both imaginary solutions. So my graph is not going to touch the x-axis anywhere. It's going to either float completely above it or completely below it. It is valuable to work this one out to see how to simplify these radicals, but we know moving forward, I've got the square root of -4, so I'm going to separate that out into +4 and -1. So I can rewrite the square root of 4 as 2. I can rewrite the square root of -1 as I. So I have -2 plus or minus 2i over -2. Now, a rule for a fraction is if I have a denominator and things are added on the top, I can break it into 2 different fractions. So I could either write this as -2 over -2 plus or minus 2i over 2. Okay, so I could write it into 2 different fractions and say, oh, well, these cancel out and those 2 cancel out. And so I get 1 plus or minus I. Another way that we could look at it is look at the top, and we could factor a -2 out. So I pull my -2 out of the front, and I'm left with 1 plus or minus I on that case. So I've got -2 on the top, -2 on the bottom. They cancel each other, and I'm left with 1 plus or minus I. So in this one, we have no solution.